Arithmetic progressions are just linear sequences, except you've never added up the terms of a linear sequence before. Any arithmetic progression can be defined in terms of its first term a and the common difference d between terms. If the terms in an AP are going up, d is positive. If the terms are going down, d is negative. There are two main formulae, for the nth term and for the sum of the first n terms. The nth term of an AP is given by the formula un equals a plus n minus 1d. Note that if an AP has n terms, its nth term is also its last term, L. It helps to be efficient writing out a specific formula for each term. So the fourth term is a plus 3d, the 23rd term is a plus 22d, and so on. The sum of the first n terms of an AP is given by Sn equals a half of n times 2a plus n minus 1d. It can also be written using the nth term L as Sn equals half of n times a plus L. A proof of the two sum formulae. Stage 1. Write out the sum of terms, a to L, backwards and forwards. So we have Sn equals a plus d, plus some more terms, finishing off with L minus d, plus L. And also backwards we have Sn equals L plus L minus d, plus some missing terms, plus a plus d plus a. For stage 2, we add up the two rows. So 2Sn will equal a plus L plus a plus L plus a plus L all the way along. For stage 3, we note that since there are n terms, there are n lots of a plus L in our sum. So 2Sn equals n times a plus L, which when we divide by 2 gives us the formula Sn equals a half of n times a plus L. To finish, we can turn this sum formula into the other sum formula. Given that L is the nth term, or a plus n minus 1d, we can substitute the L. So in the brackets we now have a plus n minus 1d, and after simplifying, a final formula of a half of n 2a plus n minus 1d. Now we shall look at some examples. In general, questions on APs require you to first identify the values of a and or d, and then use whatever value of n is required. Note that the expression below represents the sum of the first 20 terms of the AP with rth term 4i minus 1, and would be another way of writing the sum for example 1. Example 1. An AP begins 3, 7, 11, 15. Find the 20th term and the sum of the first 20 terms. So a is 3 and d is 4. N is 20 for both parts. So the 20th term is a plus 19d, or 3 plus 19 times 4, which is 79. The sum of the first 20 terms is a half of 20 multiplied by 2 times 3 plus 19 times 4, which is 820. Alternatively, you could use the last term L, which is, of course, our 20th term, 79. So S20 is a half of NA plus L, which becomes half of 20 times 3 plus 79, and 820 again. Example 2. An AP has UN equals 6n plus 2. Show that Sn equals 5n plus 3n squared. Substituting n equals 1 gives the first term of 8. Substituting n equals 2 gives the second term of 14, and hence the common difference is 6, which can also be deduced directly from the formula 6n plus 2. Substituting a equals 8 and d equals 6 into the Sn formula as shown, we find that Sn does indeed equal 5n plus 3n squared. Example 3. David puts 50p in a piggy bank on the first day, 48p on the second day, 46p on the third day, and so on. After how many days does he have £6.30 in his piggy bank? A is 50 and d is minus 2, since the terms are decreasing. Sn equals 630 in pence. So we put the Sn formula equal to 630 using a equals 50 and d is minus 2, which after some rearranging gives us the quadratic equation n squared minus 51n plus 630 equals 0. 630 has lots of factor pairs, but the one we need is 21 and 30, which in turn leads us to possible answers of 21 or 30. If we assume that it is impossible to put a negative amount of money in a piggy bank, then the answer is 21 days. If, however, we interpret a negative answer as removing money from the piggy bank, then there will also be £6.30 in the piggy bank after 30 days. Example 4. The fifth term of an AP is 17 and the 11th term is 32. Find the sum of the first 21 terms. U11 is A plus 10D, which equals 32. U5 is A plus 4D, which equals 17. Solving simultaneously by subtraction, we get 6D equals 15, and hence D is 2.5. Substituting our value of D into one of the equations, such as A plus 4D is 17, we get A equals 7. So S21 is half of 21 multiplied by 2 times 7 plus 21 minus 1 lots of 2.5, or half of 21 multiplied by 14 plus 50. To find half of 21 times by 64, you could halve the 64 and times 21 by 32, which gives us a final answer of 672.